Okay, in this question we have a stone that's thrown into the air at some angle above the horizontal. And we'll say it feels negligible air resistance, and so it should trace out a parabolic trajectory. And we want to get a qualitative sense for what the stone's speed is as a function of time. So we know that when we're treating projectile motion, we should always break down velocity into its vector components, and so that's what we're used to doing, and so it can be a little unnerving to now want to know the speed, v, which is the magnitude of the velocity vector. So I think it might be helpful to think about what each of the components of the velocity are during this parabolic trajectory. So the x component of velocity over time, what is that? That's just going to be a constant value, right? That doesn't change because we have no acceleration in x. The y component of velocity, that's what changes, right? It starts at positive, presumably this is the x and this is the y direction. So it starts out positive because the ball's moving up, and then it decreases over time and becomes negative as the ball turns around and goes back down again. And so the speed of the ball is the velocity, is the magnitude of the vector, vx and vy. And so that's square root of vx squared plus vy squared. Right? And so if you think about what that's going to be at each of these points, that speed as a function of time, it's going to be something, let's see, what about at here? It's going to be something positive here, something a little smaller here, something smaller here. It's going to be at the speed's going to be at its minimum value. But it's not going to be 0, right, because there's still an x component. Here, now Vy has gone negative, but the magnitude has both of these squared, so now the speed's going back up again, and up and up. So you can see that the speed as a function of time should look something like this, and that's most similar to this graph here. So the answer should be D. Now, I had some questions during class today. Well, what happens if, you're told that a stone is thrown into the air at an angle above the horizontal? Well, what's that angle? What if the angle is straight up? In that case, that would be a special case where there's no horizontal velocity, and in that case, C would be the correct answer. But I would say probably, if this were on a quiz or something, reading the problem, I would say the assumption is that you're at some random angle that's probably not straight up, so D is the best answer.